Imagine the thrill of opening a box that contains not just a piece of technology, but a glimpse into the future of 2026. You've just received the Tesla Bot Gen 3 Optimus, a $20,000 humanoid robot designed to revolutionize daily life with advanced artificial intelligence and seamless integration into the Tesla ecosystem. However, before this remarkable robot can start making your morning coffee or organizing your garage, you must complete 4 essential steps to activate and optimize its capabilities. In today's episode, join us as we unbox the Tesla Bot Gen 3 Optimus and detail the key actions needed to ensure it becomes a fully functional part of your life. But before we begin, please help us reach 7,000 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla Optimus and the latest news. The moment you open the box of the Tesla Bot Gen 3 Optimus, you'll be struck with awe. The sleek, minimalist packaging reflects Tesla's signature design philosophy. Inside, the robot is carefully placed. Its humanoid form is both futuristic and approachable, with a face-like screen that will soon light up with expressions and information. Standing at 5 feet 8 inches tall and weighing 125 pounds, this sleek, futuristic companion is more than just a machine. It's a partner capable of walking, talking, and learning from its environment. Equipped with the same full self-driving technology found in Tesla vehicles, Optimus promises to handle everything from mundane household chores to complex personal assistance. Connect to the Tesla ecosystem. Before you can fully appreciate its potential, the first step is to connect Optimus to the Tesla ecosystem, a network linking Tesla vehicles, solar energy systems, and smart home devices. This integration is the backbone of Optimus's functionality, allowing it to communicate with other Tesla products and operate as a cohesive part of your tech environment. To begin, you'll need to download or update the Tesla app, which serves as the command center for your robot. Through the app, you can pair Optimus with your account by connecting it to Wi-Fi or LTE, both of which are built into the robot for seamless cloud interaction. If you own a Tesla vehicle or Powerwall, Optimus can sync with these devices to carry out coordinated tasks, like opening the garage door when your car arrives, or monitoring your solar system's energy levels. This connection transforms Optimus from a standalone device into a dynamic component of a smarter, more efficient lifestyle, where it can anticipate your needs and act on them with precision. Testing basic autonomous features. Once Optimus is connected to the Tesla ecosystem, it's time to explore its core capabilities by testing its basic autonomous features. This step is not only exciting but also essential to ensure the robot functions as expected. Optimus is engineered to move with remarkable agility, capable of walking at speeds of up to 5 miles per hour, climbing stairs, and navigating uneven surfaces such as grass or gravel. Its balance recovery system enables it to regain stability if it stumbles, making it reliable in dynamic environments. To test this, you can place Optimus in an open space and command it to walk to a specific location or climb stairs, and you'll be amazed by its fluid, human-like gait. In addition to movement, Optimus excels at natural language communication, responding to voice commands with a conversational tone that feels like you're chatting with a friend. You can ask it to report the weather, sing a song, or even tell a joke, and its face display will enhance the interaction with visual cues or data. Moreover, Optimus can perform simple tasks such as picking up a bottle or handing you a cup, thanks to its highly dexterous hands with 22 degrees of freedom, closely mimicking the 27 degrees found in a human hand. Testing these features, mobility, speech, and task execution, helps you become familiar with Optimus's capabilities while verifying that its systems are fully operational, laying the groundwork for more complex tasks in the future. Software update. After completing the initial tests, the next critical step is updating the robot's software. Tesla is renowned for its over-the-air updates, which continuously enhance the performance and functionality of its products, and Optimus is no exception. These updates are essential for unlocking the robot's full potential, as they can improve its AI learning capabilities, refine its movements, or introduce entirely new features. To perform the update, you'll open the Tesla app, Navigate to the software settings for Optimus and check for available updates. If a new version is available, downloading and installing it is straightforward, provided the robot is fully charged. Its 2.3 kilowatt-hour battery offers extended runtime and connected to a stable Wi-Fi network. Recent updates have highlighted Tesla's commitment to evolving Optimus, with added features like the ability to play musical instruments or gracefully perform yoga poses. For added convenience, you can enable automatic updates, ensuring that Optimus always runs the latest software without manual intervention. This step is more than just a technical formality. It's a gateway to keeping your robot at the forefront, continuously adapting to your preferences and environment with each new release, and ensuring it remains as smart and capable as possible. Ensure safety and configure personalized settings. Finally, before Optimus can take on real-world tasks, you must prioritize safety and personalize its settings to suit your specific needs. As a highly autonomous machine, Optimus is equipped with robust safety protocols, but tailoring these to your environment is essential for secure and effective operation. Using the Tesla app, you can leverage Optimus's onboard cameras and sensors to create a 3D map of its workspace, designating areas where it is allowed to operate, such as the living room or kitchen, while restricting access to fragile or hazardous zones like a glass display shelf. You can also set movement limits, such as reducing its speed in crowded spaces, or preventing it from entering areas with pets or young children. Optimus's obstacle detection and emergency stop mechanisms provide an additional layer of safety, but proactive configuration minimizes risks. Personalization extends to teaching Optimus specific tasks, such as clearing the dinner table or retrieving items from your car. This can be done by guiding the robot through actions manually or programming tasks via the app's intuitive interface. For added peace of mind, Optimus includes a local safety chip, disconnected from the internet, which allows you to shut down the robot instantly in an emergency. By taking the time to configure these settings, you ensure that Optimus operates safely and efficiently, becoming a trusted assistant tailored to your unique lifestyle. The process of unboxing and activating the Tesla Bot Gen 3 Optimus is a journey into the future of human-robot collaboration. Priced between $20,000 and $30,000, Optimus offers extraordinary value, combining advanced automation, seamless Tesla ecosystem integration, and continuous software improvements. By connecting it to the Tesla network, testing its autonomous features, updating its software, and customizing its safety and task settings, you unlock the full potential of this groundbreaking technology. Picture a morning where Optimus prepares your breakfast, walks your dog, and updates you on the day's weather, all within minutes. This is no longer the stuff of science fiction, but the reality of 2026. As you integrate Optimus into your life, you're not just adopting a robot, you're embracing a new era where technology enhances human capability in ways once thought impossible. Whether it's assisting with household chores, supporting elderly care, or streamlining small-scale industrial tasks, the Tesla Bot Gen 3 Optimus is poised to redefine what it means to live and work alongside intelligent machines. So, as you stand before your newly unboxed Optimus, ready to take these 4 essential steps, ask yourself, are you prepared to welcome the future into your home? Elon Musk has set an extremely ambitious goal for Tesla bot production. As he mentioned, technically Tesla has enough components to build about 12,000 Optimus robots this year. But even he admits that number is quite optimistic, so the figure of 5,000 units promises to make a big splash in the market in 2025. How will this plan create a breakthrough for Tesla Optimus? Although Musk often exaggerates EV production, he has been considerably more cautious when it comes to Optimus. He stated that producing 5,000 units is currently a more realistic goal. That number may seem small for a company like Tesla, which is known for mass production, but honestly, we think it's entirely reasonable. Mass producing something entirely new is never easy, especially when Tesla is still primarily an EV automaker. There are major challenges: setting up a proper assembly line, manually assembling most of the robots rather than automating the process, and hiring experienced workers. That's why Tesla is still actively recruiting for roles related to Optimus. On top of that, there are supply chain barriers, the complexity of assembly, testing, and fine-tuning the technology. many more challenges than most people realize. Certainly, Tesla has succeeded in large-scale EV production, but building a humanoid robot is a completely different game. It requires insane precision, constant trial and error, and a lot of patience. A particularly interesting update from Tesla about the Tesla bot assembly process is that they appear to have completed a temporary infrastructure dedicated solely to robot assembly. We can clearly see up to 8 robot units nearing the completion of their exterior assembly, along with dozens of other assembly trays in the background. This is no longer just one of Elon Musk's far-fetched promises. It has become a reality. While engineers are focusing on the final assembly stages of Optimus's hands and arms, it's clear that they're paying special attention to the hand design. This unique design allows the robot to perform tasks requiring high precision, such as holding eggs, serving drinks, and many other delicate operations in the future. Interestingly, Tesla continues to go against the grain. While its competitors are focused on making robots that are smarter, faster, able to run, jump, flip, and perform flashy, often silly-looking movements, Tesla is focusing on Optimus's hands. Studies show that the ability to grasp, manipulate objects, and perform fine motor tasks is closely linked to coordination between the brain and the hands. For example, when someone plays the piano, the brain has to control each finger in sync with rhythm and keys, demanding extremely high levels of information processing. What is Tesla's long-term vision compared to its competitors? In another interesting development, Tesla is gearing up to produce the next-generation Dojo AI training system. The company has heavily invested in AI computational power by purchasing NVIDIA hardware and building its own in-house hardware through the Dojo program. The Dojo Gen 1 chips are performing well. What's truly impressive is how Tesla manages to fit 25 of these chips into a training tile, roughly the size of a dinner plate, supplying it with 15 kilowatts of power. While it's still unclear whether a full-scale Dojo system will outperform NVIDIA-based supercomputer clusters, NVIDIA is charging a premium for its chips. So if Dojo can deliver just 20% more performance at only 10% of the cost, it could absolutely be worth pursuing. Elon stated that the Tesla Dojo 2 chip will enter mass production in the next few months. Tesla Dojo 2 is said to deliver 10 times the performance of Dojo 1. If that's true, it would offer 3.6 petaflops of computing power. This would far surpass NVIDIA's H100 and could even outperform the B200 by 40%. What really matters is how Dojo 2 compares in terms of power and cost. It might be comparable to the B200 when cost is factored in. If NVIDIA sells the B200 for $40,000, but it costs them $10,000 to produce, and Tesla can build Dojo 2 at $10,000 with 40% of the performance of a B200, then it would still be worthwhile. If Dojo 2 costs $25,000 but matches the performance of a $40,000 B200, it would also be a good deal. Since August 2024, there has been growing buzz about Cortex, Tesla's massive new AI training supercluster being built at its headquarters in Austin, designed to tackle real-world AI. Musk also said it would feature huge video storage capacity for training FSD and Optimus. When compared to the development of one of the humanoid robotics companies in the United States, Figure AI recently revealed a major breakthrough, one that led the robotics startup to end its relationship with one of its investors, OpenAI. The company had plans with Helix to combine high-level reasoning systems with real-time motor control. These two systems truly narrow the gap between object understanding and physical action, or motor control. Although Figure AI has a similar approach to Tesla in using in-house artificial intelligence, it appears to lack a clear and concrete long-term strategy for AI training technology. In contrast, Tesla first mentioned Dojo back in 2019 and officially launched it in 2021. Now, just 4 years later, Tesla is already planning to scale up production of its next-gen training clusters and has completed the deployment of Cortex, comprising around 50,000 NVIDIA H100 GPUs. Tesla has truly upgraded Optimus at an incredible pace. Optimus Gen 3 is expected to be released in 2026, after the production line for the current version stabilizes. Tesla will allow customers to experience Optimus in select strategic business areas. This will be the most advanced version available for purchase, and its price could be significantly higher than previous models. The initial price could reach up to $50,000, but it will be able to handle any task you assign to it. We think it will be very interesting even just to interact with the Tesla bot on a daily basis. I mean, you don't need to be cautious or overly polite, and it doesn't stop there. If this robot can remind you to take your medication on time, report upcoming appointments, or even help the elderly get familiar with technology by offering simple, easy-to-understand guidance on how to use smart devices like phones and tablets. So, what features and design elements has Tesla Optimus been equipped with to take over? Tesla Optimus Gen 3, unveiled at the We Robot event in 2024, marks a major leap from the Gen 2 version. Featuring 22 degrees of freedom in its arms, integrated full self-driving AI, and the ability to perform a wide range of tasks, from household chores to industrial operations, Optimus Gen 3 is expected to reshape the future of automation. Elon Musk has stated that this robot is not just a technological product, but also a key to Tesla reaching a market valuation of $25 trillion. Meanwhile, competitors from China are rapidly closing the gap. Qinglong, developed by the National and Local Joint Engineering Research Center for Humanoid Robotics in China, impresses with 43 degrees of freedom and the ability to handle household tasks through voice commands. PX5 from XPeng Motors, launched in 2023, stands out for its agile movement and industrial applications. The G1 from Unitree Robotics, offered at a competitive price, focuses on agility and adaptability in dynamic environments. The battle between these robots is not only about technology, but also about pricing, mass production capability, and market acceptance. One of Tesla Optimus Gen 3's biggest advantages is its target price range of $20,000 to $30,000, significantly lower than earlier predictions for the humanoid robots, which typically range from $50,000 to $150,000. According to a report by Goldman Sachs, material and manufacturing costs have been declining faster than expected, about 40% per year, enabling Tesla to reach this competitive price point. Elon Musk also revealed that the production cost of Optimus could be as low as $10,000, which would allow for a high profit margin if sold at $20,000. Among its competitors, Unitree's G1 is the most affordable option, with a starting price of $16,000, a significant drop from the previous H1 model, which was priced at $90,000. Qinglong has not yet announced an official price, but with backing from the Chinese government, it may be priced low to compete in the global market. Meanwhile, the PX5 from XPeng Motors starts at around $30,000, making it more expensive than both Optimus and G1, but justified by its advanced features and industrial applications. In terms of pricing, the Optimus Gen 3 holds a middle ground, directly competing with Qinglong and outperforming PX5, though it still faces pressure from the more budget-friendly G1. However, when it comes to technical features, a core factor in evaluating the capabilities of humanoid robots, Optimus Gen 3 stands out with several notable strengths that seem to surpass all competitors. The robot has around 40 degrees of freedom across its entire body, including 22 in its hands, allowing it to perform complex actions like playing the piano or folding clothes. Its maximum walking speed of 5 miles per hour is 30% faster than Gen 2, making Optimus suitable for environments that demand agility, such as manufacturing plants. The end-to-end AI from FSD enables the robot to learn and adapt to new tasks without reprogramming, offering a major advantage in diverse applications. Weighing 57 kilograms and capable of carrying loads up to 20 kilograms, Optimus strikes a balance between durability and performance, while delivering a battery life of over 10 hours, outperforming many of its rivals. Qinglong leads in degrees of freedom with an impressive 43, allowing for more refined movements. However, the number of degrees of freedom in the hands, arguably the most critical for task handling, has not been disclosed by the manufacturer, making it difficult to assess its dexterity. Additionally, Qinglong's movement speed is only around 3 miles per hour, slower than Optimus, and its AI primarily relies on voice commands, falling short of high-level automation. PX5 from Xpeng Motors features around 40 degrees of freedom, a walking speed of 7 kilometers per hour, and environment recognition AI. But it has yet to be proven effective in handling complex tasks like those Optimus can manage. Unitree's G1, with 43 degrees of freedom and a speed of 7.2 kilometers per hour, is the lightest robot in the group at just 35 kilograms. But it can only carry up to 10 kilograms and offers a battery life of around 6 hours. Overall, Optimus Gen 3 stands out thanks to its advanced AI, higher walking speed, and proven hand dexterity. How Tesla maximizes profits compared to humanoid robot competitors. Tesla's vision for Optimus Gen 3 goes far beyond simply creating a product. It aims to spark a revolution in automation. Elon Musk predicts that global demand for humanoid robots could exceed 20 billion units. And Optimus is positioned to meet this demand across sectors ranging from households and industry to healthcare. Tesla plans to begin small-scale production in 2025 for internal factory use, before scaling to mass production for external companies in 2026. With a target price of $20,000 to $30,000, Optimus will be significantly more accessible than traditional industrial robots, which often cost hundreds of thousands of dollars. The robot is designed to handle all kinds of tasks, from household chores like cleaning and cooking to assisting with car assembly in Tesla factories. By leveraging its experience in electric vehicle manufacturing, Tesla can optimize production costs and scale efficiently, with plans to deploy over 1,000 Optimus units in its own factories by 2025. Meanwhile, Unitree and Xpeng are focusing on niche markets, such as AI research or manufacturing, while Qinglong is strongly backed by the Chinese government to dominate both domestic and international markets. However, Tesla faces significant challenges in this race. Chinese robots like Qinglong benefit from major investments in government incentives, which help reduce production costs and accelerate commercialization. China, already a leader in the electric vehicle market, is pursuing similar ambitions in the humanoid robot sector. Startups like Agabot, backed by BYD and Warburg Pincus, also pose a threat, quickly rolling out low-cost models like the Expedition A1, with plans to produce 5,000 units by 2025, rivaling Tesla's own targets. Another issue lies in questions about the true autonomy of Optimus Gen 3. Some experts, such as Josh Wolf from Lux Capital, have suggested that the robot's actions during the We Robot event may have been remotely controlled rather than fully autonomous, raising doubts about the readiness of its AI technology. These concerns could affect investor and consumer confidence, forcing Tesla to prove the robot's real automation capabilities in upcoming trials. Overall, Tesla Optimus Gen 3 is leading in artificial intelligence and mobility speed, with an ambitious vision for mass production. However, Unitree G1 holds a price advantage. Qinglong excels in flexibility, and PX5 is well-suited for specific industrial applications. The competition from China, combined with the rapid pace of innovation among startups, will force Tesla to continuously improve to maintain its lead. The humanoid robot market is open, and the ultimate winner will depend on who can best balance technology, affordability, and market accessibility. So, which robot are you betting on? Optimus with Elon Musk's world-changing ambition, or the fast and cost-competitive challengers from China? Share your thoughts in the comments below, and stay tuned for more exciting tech updates. As the electric vehicle market sees more and more automakers emerging from China to North America, the pressure on manufacturers is increasing as they must make breakthroughs in battery technology that are at least cost-effective, energy-efficient, and safe. It seems Tesla can no longer remain loyal to lithium batteries, as this battery technology is not part of the plan for producing an affordable car. The new path is advanced sodium-ion batteries, which can be recharged in just 5 and maintain 100% stability after 5,000 charge-discharge cycles. So, what if Tesla had a battery that is 3 times cheaper than lithium-ion, charges twice as fast, and is 100 times safer? A research team from Korea Advanced Institute of Science and Technology has developed a prototype sodium-ion battery that challenges traditional lithium-based competitors. The battery utilizes a unique combination of electrodes, This approach allows it to operate with a performance level comparable to lithium-ion solutions. The new sodium battery design boasts a power density of 34.75 watt per kilogram, setting it apart from previous sodium-based solutions. Moreover, it achieves an energy density of 247 watt-hours per kilogram. These performance metrics make it competitive with lithium models currently available on the market. According to the developers, this combination enables the device to achieve high storage capacity and fast charge-discharge rates, making it a viable alternative to lithium-ion batteries. However, the researchers discovered that developing a hybrid battery with both high energy and power density requires addressing the slow energy storage rate of the battery type anode, as well as enhancing the relatively low supercapacitor type cathode material. Ultimately, this breakthrough overcomes the current limitations of energy storage systems and is expected to be widely applied across various electronic devices, electric vehicles, and aerospace technology. In terms of durability, the battery maintains 100% stability after 5,000 charging cycles. Users can flexibly fast charge the battery in just 5 seconds, although models with longer autonomy have slightly longer charging times, extending up to 1 hour. The new sodium battery uses 2 separate metal-organic frameworks to synthesize an optimized hybrid battery. This method led to the development of an anode material with improved kinetics by incorporating fine active materials into porous from metal-organic frameworks. In addition, a high-capacity cathode material was synthesized, and the combination of both the cathode and anode materials enabled the development of a sodium-ion storage that optimizes balance and minimizes the disparity in energy storage rates between the electrodes. How ready is sodium-ion battery technology for mass production? CATL, China's lead manufacturer and also a battery supplier for Tesla's electric vehicles, has announced mass-produced sodium-ion batteries specifically designed for electric vehicles. This announcement is part of the brand's commitment to advancing sustainable energy solutions. Branded under the new name Naxtra, these batteries represent a significant step forward in addressing performance demands under extreme weather conditions. Sodium-ion batteries are designed to deliver reliable performance, especially in cold climates that can challenge traditional lithium-ion technology. These batteries maintain stable energy storage even at temperatures as low as -20 degrees Celsius, making them ideal for regions with harsh winters. For sodium-ion battery packs intended for electric vehicles, CATL also stated that these batteries can be charged up to 80% in just 15 minutes under normal temperature conditions. Although this charging time is significantly longer compared to Korean technology, it is understandable, since a single battery cell capable of recharging in 5 seconds would naturally require more time when scaled into a large battery pack for us. This sodium product line includes 2 distinct models tailored for passenger cars and electric trucks. These batteries boast an energy density of 175 watt-hour, as well as with lithium iron phosphate batteries, making them the highest energy density among all sodium-ion batteries. Designed for all-weather performance, the Naxtra battery 90% of its usable capacity at -40 degrees Celsius and can withstand temperatures up to 70 degrees Celsius. With a driving range of 310 miles and over 10,000 charge cycles, this battery reduces while ensuring reliability for EV users. What is the potential of sodium-ion batteries for Tesla? Have you ever wondered why we should switch to sodium-ion batteries when lithium-ion batteries are already considered the gold standard? The simple truth is that lithium batteries can't address challenges electric vehicles currently face, especially as most automakers are shifting toward more affordable EVs. One of the main reasons sodium-ion batteries are being developed is more abundant and cheaper than lithium. This becomes particularly important as the demand for lithium continues to rise, with a projected shortage of lithium needed for lithium-ion battery production by 2026. Sodium-ion batteries in particular offer advantages for all automakers, especially for Tesla and the highly anticipated 25,000 vehicle that Elon Musk often mentions. The lower cost is a key benefit, as introducing a new battery chemistry that doesn't rely on lithium brings significant value. Especially in the future, lithium demand is expected to increase 500-fold compared to current levels. What do you think about this? Feel free to share your thoughts in the comments section below. We hope to bring the best information to you, Please give a thumbs up if you like this. Join Techno Creator by subscribing and hit the bell icon so you will not miss out on any awesome videos. We value your feedback. Thanks for watching. Until